In this video, we're going to do a brief overview of Diagnostics in Express. Rather than going into the settings and optimizations, we'll be focusing on the creation of turnkey diagnostics in Express and looking at what you can do with them. Let's begin by creating a diagnostic session. First, make sure you save your design because it will load your information from the disk. And then we'll select this Show Diagnostics button to create a diagnostic study that is linked to this current design. This will create a separate document type that we can use to perform diagnostic analysis within Express. At this point, to create a diagnostic strategy, all we have to do is select a few options. We'll look at hierarchy first, and since this is a flat model, we don't have to set anything on this panel. For the detection options panel, we'll select the specific test sets that we want to use for fault detection. On the isolation panel, we'll choose those test sets that contain tests that will be used to localize or isolate the failure. The last change we'll make is to select an algorithm. For this example, we'll select an algorithm called Common Cause Half-Split Failure Probabilities. It is worth noting that this is the algorithm that is normally selected when performing a testability study on most military-related projects, since its calculations are to be based upon the diagnosing for single faults. This is typically the method used in conforming to the testability requirements on most projects, so this is the algorithm we will use to produce those deliverable statistics. Express has many other algorithms to best reflect the optimizing of fault detection and isolation that are explored in other advanced video tutorials. Now we'll click here to calculate the diagnostics, and click Generate, and it will automatically generate a diagnostic tree on the left side. The tree represents your diagnostics as if it were a troubleshooting procedure. If it is a troubleshooting procedure, then this is simply just a true-false tree. So if the test passes, you'd move down the tree, and if it fails, you'd move right in the tree. Each node in the tree represents either a test performed or an isolated fault group. We can use the arrow keys to move to the right, and as we step our way through the tree, the colors in the drawing on the right change to reflect our diagnostic status. Here we isolated to a fault group containing the RS line. The various colors you see will be explained in another video in this series. This same tree can also be used if we're developing runtime diagnostics or some sort of embedded diagnostics that use fault codes, and we can evaluate this fault coverage as it isolates to the failure. So this tree can represent either troubleshooting for field maintenance, or it can be used to represent the way in which we can parse through fault codes to determine the actual fault or failure in a runtime diagnostic environment. Once we've created the diagnostic flow diagram, we can also evaluate it in a manner similar to how diagnostics would appear in a runtime IAM environment. In other words, we can call up a diagnostic session and step through the tree, saying which tests pass and which tests fail. We can also insert faults. So we can say, what would be represented in the diagnostics if the battery fuse was to fail? And you can either step through the diagnostics answering the tests on each test node, or we can just click on Diagnose Fault, which will take us directly to the fault group in the tree, showing how Express isolates that failure. We will look at this feature in a little more detail in a later video in this series. So we have this tree, and you can examine it and see if it's accurate using desktop fault insertion. But at the same time it produced it, it also created statistics that reflect the testability or expected diagnostic performance of your design with these diagnostics. For example, we can identify that the fault detection or the FD portion of the FD-FI calculation show a probability of detection to be 99.79%, and the fault isolation or FI to a single item to be nearly 75%. In some industries, we can equally describe this example as having the fault coverage of 99.79% and a fault resolution or fault diagnosis of 74.26%. We will go into these numbers and some of the other numbers we see on the screen in a later video in this series. Just recognize right now that it creates these automatically. Once we've generated the statistics, we can also view the diagnostic reports. There's a wide and extensive variety of diagnostic reports, but for this video we'll look at the Fault Group Rankings report. This takes all of the isolated fault groups and ranks them in order of their impact upon various aspects of your system. These are the top 15 fault groups that impact your testability statistic in terms of the number of items contained within the fault groups or fault group ambiguity, when combined with likelihood or frequency of failure of any of those items in the fault group. So the top group in this list is a large group with a high probability of failing, which would hurt your testability the most. As we scroll down, we can observe that we had a few more of these ranking reports that are generated concurrently, including a report on how well we're splitting up our critical failures. Let's look briefly at the table showing the top 15 fault groups ranked by their impact on repair time. The first group listed in this report identifies the fault group that is contributing the most to a high mean time to repair, or MTTR, since it has a high repair time and a high failure probability. This report is particularly useful for large systems where it may not be otherwise apparent what areas of your system might prevent you from meeting your maintenance and support goals, which makes this ranking report very useful. When we click on any of the fault group hyperlinks, we can discover extensive details within any of these fault groups. Now let's briefly look at the diagnostics. This Export Diagnostics button on the toolbar provides us with the means to export the fully structured diagnostics from our model. When we click on this button, it will invoke the DiagML options dialog. DiagML is a popular XML schema that is used by Express to transfer diagnostic data to a number of other environments for complementary purposes. This dialog contains a variety of fields that can be turned on or off. However, to make exporting easier, this drop-down menu provides us with a selection of pre-selected or default export configurations. For example, if we wish to export the data necessary to perform a stage operational support simulation from our model, we would simply select this stage configuration. Likewise, if we desire to export to the DSI Workbench Maintenance Reasoner, we would select this configuration that properly packages the dataset for this purpose, and so on. Other configuration preselects allow the diagnostics to be used in other third-party onboard or offboard reasoners, iEDMs, and embedded applications. In summary, the model data is not only available to be used for testability calculations, but also for the simulations, the runtime applications, and a wide variety of continued support purposes. To export, simply select where the file is to be saved, and it's just that simple.